Piecewise functions are graphs that include a piece of one function and a piece of another function considered together on the same grid. Now, they're called functions because they are going to pass the vertical line test. That's very important. These are piecewise functions, and we can't forget the fact that a function passes the vertical line test. First thing I do is I count how many different pieces I have for a particular function. G of x equals x squared if x is less than 2, and it equals 1 over x if x is greater than or equal to 2. So there's two different pieces going on here. So I highlight each piece in a different color, and then I go over to the x-axis, and I say when x is less than 2, that's yellow. So x is less than 2 is yellow. And I highlight the x-axis in that yellow. And then the other piece, 1 over x, if x is greater than or equal to 2. So I go over to 2, and greater than or equal to, I highlight that in green. So you can see that the two colors meet together at x equals 2. So I'm going to start at that meeting point, x equals 2. I'm going to go to the left, which means I'm going to be putting 2 into the yellow function. And then I'm going to go to the left and put 1 into the yellow function. And then I'm going to go to the left of 1 and put 0 into the yellow function. And then put negative 1 into the yellow function. So I'm going to keep putting these values into the yellow function so that I can get a picture of what's happening on that piece. So let's make that a little bit smaller there. And let's get started. So we put a 2 into the yellow function, but it says x is less than 2. So when I put that 2 into the yellow function, it's going to be an open circle because we don't have the equal to part on the inequality. So we put 2 into the yellow function, and I get x squared, so 2 squared is 4. So when we put a 2 into the yellow function, we're going to get a 4 out. And that's an open circle. Actually, let's do this. I can make this look even better. I like it when I've got that confidence in myself. So I'm going to put a 2 into the yellow function. Then I'm going to put a 1 into the yellow function, then a 0, then a negative 1, and so on and so forth. And that's all going into the yellow function. So those are all the inputs. And then we're going to put 2 into the green function, right? Because they meet right here at 2. So we put 2 into the green, or into the highlighted green function, and we're going to get an output. And then we'll put a 3 in, then we'll go to the right, and then we'll put a 4 in, and then a 5 in. And we're going to highlight that in green. So when we put this 2 into the yellow function, because the yellow function doesn't have the equal to part on the inequality, it's going to be an open circle. However, when we put the 2 into the highlighted green function, it is included. See, that is included. Therefore, that's going to be a closed circle. And this way, 2 is only going to have one legitimate output. So we put that 2 in. I'm going to put that 2 in to the yellow function, and 2 squared is 4. We put a 1 into the yellow function, and 1 squared is 1. Put a 0 into the yellow function, 0 squared is 0. Put a negative 1 into the yellow function, and negative 1 squared is 1. So 2, 4, and that's an open circle. And then 1, 1, and then 0, 0, and then negative 1, 1. And if we put a negative 2 in, negative 2 squared is 4. If we put a negative 3 in, negative 3 squared is 9. So this graph will continue to go to the left forever, and then it's going to curve around, and it's going to hit that open circle and stop. And now we're going to, I don't know if yeah, I think I did. Okay, now we're going to put 2 into the green function. So 1 over 2 is 1/2. And then we put a 3 in. 1 over 3 is 1/3. And we put a 4 in and we get 1/4. And we put a 5 in and we get 1/5. And it's going to get these fractions are going to continue to get smaller. So we put a 2 in. I'm going to definitely have to make this pen smaller. Put a 2 in and we get a 1/2 out. And that's a closed circle. Put a 3, get 1/3 out. 4, 1/4. 5, 1/5. So it's getting very, very, very close to 0. It's never going to quite be 0. 1 over 10 is going to be 1/10. 1 over 100 is going to be 1,000. So it's just going to get very, very close to that x-axis, and it's going to continue to the right forever. And that is a piecewise function. And you can see that it does pass the vertical line test. It's a pretty nice, other than the 1 over x graph, it's a pretty nice piecewise function. Okay, let's try another. This one says h of x equals the absolute value of x if x is between -1 and 1. So I'll use blue. -1 to 1 on the x-axis. And then I'm going to use orange to do the second piece, the square root of x if x is between 1 and 4. And this is interesting because they both have x is equal to 1. So those inputs need to have the same outputs. Otherwise, we're going to have some problems. So let's see what we've got here. When we put in -1, I'm going to look at the blue function, and I'm not going to make the table this time. If you want to make the table, you can. I'm just going to say, you know what, if you put a -1 in, we know it's going to be a closed circle because of the equal to sign, and we're putting it into the blue function. So when I put a -1 in to the blue function, I'm going to get an absolute value of -1, which is +1. So I put a -1 in and I get a +1 out. I put 0 in to the absolute value function, I get 0 out. We put 1 in, the absolute value of 1 is 1. And this is a straight line, just like that. It's the absolute value function. Now we go to the orange function. When I put a 1 in, I need to get a 1 out. And I absolutely do. I get a 1 out. So the absolute, or the square root of 1 is 1. So it lands right on the other point, which is very important. Now when we put a 2 in, the square root of 2 is about 1.3-ish. Now I know that, but you might not know that. So you might skip that. The square root of 3 is about 1.7-ish. I know that, but you might not know that. So we put a 4 in. The square root of 4 is 2. So we put 2, we could put 4 in and we get 2 out. And then that's a curve, just like that. And that also is a function because it's going to pass the vertical line test. But it doesn't continue to the left forever, and it doesn't continue to the right together forever. It's got endpoints, and that's because of the way our domain was written. Okay, here's one for you to try. Go ahead and try this, and then come on back and see how your graph looks compared to mine. It's going to look fantastic. Okay, welcome back. I used yellow and green again, and I highlighted x is less than 0 in yellow, and x is greater than 0 in green. And then I might just say, hey, what's happening at 0, right? Well, 0 on the yellow function, and then 0 on the green function. So 0 and then -1, and then 0 and +1. 0 on the yellow function is a closed circle. 0 on the green function is an open circle. When I put 0 into the yellow function, I get a 0 out. When I put -1 into the yellow function, I get a 1 out. So 0, closed, 0, 0, -1, 1. I'm going to need some more points here. I'm going to put -2 into the yellow function, I get a 2 out. Put a -3 into the yellow function, I get a 3 out. -4, 4, -5, 5, -6, 6. See, this is all the absolute value function right there, which is a straight line to the left of x equals 0. Now we're going to graph x squared when x is greater than 0. So again, we have to put that 0 in. I'm going to do this in gold. So we have to put the 0 in. So we put the 0 into the green function and we get a 0 out. And it's an open circle. But the open circle is filled in by this closed circle. So that's the important part of this graph, is when you've got an open circle and a closed circle on top of one another, the closed circle fills in the open circle. So you can't see the open circle. Then you put a 1 in. 1 squared is 1. Put a 2 in. 2 squared is 4. So 1, 1, 2, 4. Put a 3 in. 3 squared is 9. This is not a straight line. This is a curve. And it continues to the right forever. And that is what the piecewise function looks like. So hopefully this was a good review of piecewise functions for you. Maybe the color of the axis was new for you, coloring each piece in a highlighter. Hopefully that gives you the visual. I've also seen, let me just show you, I've also seen some teachers, it must be teachers teaching it, because students do something like this. They'll take their pencil and they'll do something like this. They'll say x is less than 2. And they'll just do this. They'll separate out the graph, the grid, into 2 parts. To the left of that gray vertical line and then to the right of that gray vertical line. They'll do the same thing here. They'll say from -1 to 1. So they'll say, okay, from -1 to 1, in between those 2 gray lines, we've got a particular graph. And then from 1 to 4, we have a particular graph. And then here they'll say at x equals 0, and they'll do something like that. And they'll say, to the left of that gray line and then to the right of the gray line. So I like to use the colored highlighters because it helps me see. I was not always a visual person, but I became a visual person, and I equate it to watching TV. We can watch TV in black and white, and some things are really great in black and white, but we've come very accustomed to the vibrant colors and the depth and the detail that we can notice in color. And when we use that color in mathematics, it really can help us understand, it can help us see things that we normally wouldn't see in black and white.